So it's actually serendipitous, really. I was an undergraduate student at the University of Derby when I was early for a field trip, and I went into the university shop, and it was at this time that Jamie Thompson published his derivation of hESCs, and I was absolutely captivated by these cells who had the potential to go on in regenerative medicine and cure all these diseases. So I then spent 2 years teaching my university lecturers at any opportunity I had how wonderful these cells were. And then I went up to Edinburgh and did my PhD up at the Rosslyn Institute in stem cells, and it kind of went from there. So I came down to the University of Sheffield in 2006, where I took on the role of quality manager for the stem cell derivation facility. And essentially when I got down here, Prof Harry Moore said, "We've built a clean room, make it work." And I went, "You've built a what?" So I had to teach myself about GMP and quality management systems, and we set up the clean room. It was probably operational back end of 2009. We derived our first cell line in there in 2010, and then we're fairly successful between 2010 and 2013, where we made 14 cell lines, the MasterShef cell lines. And in that I did all of the quality management. I wrote the entire quality management system, and I ran the sort of operational side of things as well for Prof Moore. And then I went off on maternity leave and came back, and that's when I took on the job of a project manager for the UK Regenerative Medicine Platform. So this is a translational alliance between the University of Sheffield, University of Loughborough, University of Cambridge and the UK Stem Cell Bank. And we're looking at trying to understand the bottlenecks that there are in translating pluripotent stem cells from bench to the clinic, and we're working a lot with Roger Barker at the University of Cambridge in his Parkinson's disease clinical trial that he's trying to get set up. So I've been doing that for now just a little over 12 months, and I've got another 12 months left to go. So back in 2005, the new legislation was coming in from Europe, which had the European Tissue and Cells Directive, and the MRC at that time had set up a fund to set up these different derivation facilities, and there were 5 across the UK, of which Sheffield was probably the lead, the most advanced in its development at the time. And when I came down here, that was my dedicated role, to get that set up and running. The idea being that we were kind of trying to run before we could walk, really, because we knew that in order to get cells into the clinic, that the starting material had to be of a certain quality, and we had to consider the safety aspects of it. And the research grade human embryonic stem cell lines had been exposed to serums, mouse feeders, and so we knew that we needed to have clean versions of them. But obviously every single embryonic stem cell line is different, it's different genotype, they behave slightly differently. So in order to get a cell product at the end, you needed to start with a material that you knew was going to go from start to end, whereas to do a lot of research on the research grade hESCs and then move to a clinical grade version, it could be that the protocol you just spent 10 years developing didn't work. But the legislation wasn't really in place, no one really understood how everything was going to fit together, so I spent a lot of time trying to work with the HTA and the MHRA and the HFEA to try and work that through. So that was kind of the driving force, really, was just to generate starting materials that we knew would be acceptable from a regulatory point of view, so that we could give a level of assurance to people developing therapies that what they'd started with would be good quality. So to start with, when we first went into the clean room, we wanted to work with a system that we knew was successful. So we started MasterShef 1 to MasterShef 9 were derived using the standard KOSR media, and we'd replaced mouse feeders with human feeders. And so we'd done that successfully 9 times, and we were like, okay, we don't need to do that anymore. So we then started to look at replacing the bovine element of the serum with a humanised version or a xeno-free, and we wanted to remove the feeders. So we tested a number of medias at the time, as one of which was Nutristem, and it worked really nicely. And the nice thing about the Nutristem was it wasn't developed with a specific matrix. So it was marketed as being able to be used with a number of different matrices, whereas a lot of the other ones at the time had been developed with a specific matrix. So the other thing we really liked about it was that it was complete media when it came in. So you eliminate the possibility of somebody making it incorrectly. So the other thing is that we were able to batch test and reserve large quantities of the media. So it just meant that we could remove variation from our process, which in the clean room was gold, really. So the media worked nicely, the ESLs liked it, and we used the Nutristem XF, so the feeder-free Nutristem, but we used it with and without feeders, so we didn't use the two different medias. So the first cell line that we generated with Nutristem was MasterShef 10, and that was actually on human feeders, and MasterShef 12 was also on human feeders, both in Nutristem. But then MasterShef 11 was laminin 511, MasterShef 13 was Cell Start, and MasterChef 14 was laminin 521, and the Nutristem worked with all of them. So it was just versatile. For us, it was when we were looking for a new media in the clean room. It was important that we knew it would be regulatorily compliant, and biological industries were really helpful to begin with when we were assessing that. So we were able to get certificates of origin for the serum components. We were able to make sure that it was free of any adventitious agents or known human pathogens. So that was quite critical. It was critical that it was easy. So some of the other medias, you had to mix this specific component in this specific bottle, and it was open to error, human error. So it needed to be simple. The Nutristem media, again, it has a 2-week expiry on it from thaw. So we've been able to practically eliminate waste of media because we would thaw it out, aliquot it, refreeze it, and then use a smaller aliquot at a time. So we don't throw media away anymore. It's reliability, isn't it, and reproducibility. If you've got confidence in your culture system, embryonic stem cells are the most challenging cell type to work with because they're unpredictable. So if you've got anything that makes that predictability more reliable, then you've got a fighting chance of getting where you want to be, really. So I think you need some of the medias where you keep ES cells completely undifferentiated with no spontaneous differentiation at all, I'm sceptical of, because yes, you want to keep your ES cells undifferentiated, but there's no point having undifferentiated ES cells if you can't then differentiate them in the future. And so I think personally, a level of spontaneous differentiation is healthy in a culture, and we still see that with Nutristem. So we're really pleased to see the odd bit of differentiation. So it basically means the UK Stem Cell Bank have validated everything that we've done in Sheffield independently. So we thought they were compliant with the European Tissue and Cells Directive, which would therefore allow them to be considered to be used for potential human application. So we've had a licence here in Sheffield since 2008, which has been audited by the HTA, and so now an independent party has confirmed, based on the documentation we've provided, that they also consider it to be EUTCD compliant, which essentially gives it a rubber stamp to be distributed and to be considered for use in human application. So it's really important, and I'm sure that because MasterShef 2, 7 and 10 have got that gold stamp, then all of the others were derived in the same way. So I'm hoping that in the near future all of them will be given that stamp. The major challenges was, I guess it was a completely new culture for stem cell biologists to consider working in. So up until that point, we didn't really know what GMP was. We didn't have a good appreciation of the level of paperwork, of the level of extra time it took to do everything, and the impact that had on what we were trying to achieve. So you say, yeah, we'll make this bottle of media up, which is a 2-minute job, but it's a 7 or 8 minute job if you've got to fill in all the paperwork and the traceability that's involved in that. So it was a complete culture change. The process of deriving embryonic stem cells isn't defined. It still isn't really understood, and to try and do that in a quality controlled environment was incredibly challenging, because a lot of it was reliant on experience, and you can't write an SOP that says have this level of experience and know what to do in this circumstance. So that was quite challenging. And also we were at the forefront, so the regulation was new. People didn't really understand, and to begin with, embryonic stem cells were forgotten about. We fell down a hole. So to try and get our voices heard to say we need regulation was a bit alien, because no one really likes to be regulated. But actually we needed that seal of approval to say what we were doing was correct, because we couldn't go back and redo it. So trying to get that balance right of having regulation but not being over-regulated, because we had a process that wasn't definable at that time, and to some extent still isn't, was a challenge. Ultimately, the outcome, I would like to see one of the MasterShef cell lines go through differentiation and into clinical trial. And in fact, not one of the MasterShef lines, but a re-derived version of one of the chef lines has done that. So that went into a clinical trial for macular degeneration, and that has to be one of the proudest moments I have. And I guess these cell lines, we've got them as clinical grade versions, but we've also got research grade versions of all of the clinical lines. So I'm hoping that people will just take them and use them and see what they can do. And I just hope we can get rid of some of these nasty diseases and give people a fighting chance. So the pluripotent stem cell platform is still ongoing until March next year, which I'm hoping we will be able to extend. They're hopefully going to release some new funding for UK RMP2 in the next few days, so we're hoping to be able to do some further development of the genetic instability work, particularly that we're involved in here in Sheffield. So yeah, fingers crossed.